So far we completed different topics in electromagnetic induction and alternating current and their formulas. Right. Now I am going to solve some problems. Right. First problem: the magnetic flux pi in a closed circuit of resistance 5 ohm varies with the time t second. According to the relation, pi is equal to 16 t square minus t plus 5 Weber. Then induced current at t equal to 0.225 second is, right, induced current we want to find out. We know that induced current I is equal to induced EMF divided by resistance. Induced current I is equal to induced EMF divided by the resistance. Right. What are the given values? Resistance of the circuit R is equal to 5 ohm. And next time dependent flux pi is equal to 16 t square minus t plus 5, and next to time t is equal to 0.25 second. And induced current formula is equal to E divided by R. E induced EMF. Induced EMF is d pi divided by dt divided by R. Therefore, I is equal to d divided by dt into R of pi formula or pi equation 16 t square minus t plus 5. Right. I is equal to differentiation of 16 t square minus t plus 5, 32 t minus 1 plus 0 divided by R. Right. The time value is 0.225. So 32 into 0.225 minus 1 divided by resistance value, so 5 ohm. 32 into 0.225, 8 minus 1 divided by 5. 8 minus 1, 7. So 7 divided by 5. 7 divided by 5, 1.4 ampere. Right. The magnetic flux of pi in a closed circuit of resistance 5 ohm varies with the times t second according to the relation pi is equal to 16 t square minus t plus 5 Weber. The induced current at t equal to 0.2 seconds is 1.4 ampere. The relation is I is equal to E divided by R. Induced EMF formula d pi divided by dt. Right. Differentiation of pi is 32t minus 0, so minus 1 plus 0 divided by R. T value is 0.25. So after simplifying this, we can get I is equal to 1.4 ampere. B option. Second problem. A coil of cross-sectional area 10 square centimeter square is placed in the magnetic field which changes to 4 into 10 power minus 2 Weber per centimeter square within 5 seconds. What will be the current across the 5 ohm resistance? Right. Once again, current I is equal to induced EMF divided by resistance. Induced EMF by changing the magnetic field is given by E is equal to minus NA into dB divided by dt. Here negative sign indicates Lenz's law. So therefore I is equal to NA into dB divided by dt divided by R. Right. In this question, number of turns value is not given, so n value is taken as 1. And the area of cross section value 10 square centimeter square. And changing magnetic field, that is the dB value is 4 into 10 power minus 2 Weber per centimeter square. And time, suppose dt is 5 seconds. And the resistance R value is 5. Right now substitute all the values in this equation. I is equal to n value 1, a value 10 square into dB value 4 into 10 power minus 2 divided by dt value 5 second and R value also 5. Right, 10 power plus 2, 10 power minus 2 cancel. 4 divided by 25. 4 divided by 25 can be written as 100 divided by 4. 4 goes to numerator, so 16 divided by 100. 16 divided by 100, 0.16 ampere. So the current across the 5 ohm resistance is 0.16 ampere. Right, the formula I is equal to induced EMF E divided by R. Here the EMF is induced by changing the magnetic field. So EMF formula E is equal to minus A N A into dV divided by dt. Here negative sign indicates only Lenz's law. So therefore I is equal to E N A into dV divided by dt divided by R. So substitute all the given values in this question, we can get current value. The current value obtained is 0.16 ampere. B option. Next, third problem. A horizontal straight wire 10 meter long extending east and west is falling at right angles to the horizontal component of Earth's magnetic field 0.30 into 10 power minus 4 Weber per meter square. If the induced EMF is 1.5 into 10 power minus 3 volt, the velocity of the wire is, right? So east, west, the wire is extending east and west direction, which is falling vertically downward. Actually, the horizontal component of Earth's magnetic field is always acting north-south direction. When the wire is falling vertically downwards, the wire cuts off the horizontal component of Earth's magnetic field, right? Due to this, an EMF is induced across the wire. So induced EMF value is given, that is 1.5 into 10 power minus 3 volts. We need to calculate what is the velocity of the falling wire, right? So the equation for this question, E is equal to BL, that is motional EMF. Motional EMF formula E is equal to BLV. Right? The given values are, the horizontal component of Earth's magnetic field value is 0.30 into 10 power minus 4 Weber per meter square. And the length of the wire is 10 meter. L is 10 meter. And induced EMF value also given, that is E is equal to 1.5 into 10 power minus 3 volts. We need to calculate the velocity of the falling wire. The relevant formula E is equal to BLV. Therefore, V is equal to E divided by B. Induced EMF 1.5 or 15 into 10 power minus 4. And magnetic field 0.30 into 10 power minus 4 or 3 into 10 power minus 5. 3 into 10 power minus 5. And length value is 10. 10 power minus 4. 10 power minus 4, 10 power minus 4 cancel 5 times. So velocity of the wire V is equal to 5 meter per second. The option is D option. 5 meters second power minus 1. Motional EMF formula E is equal to BLV. B value 0.30 into 10 power minus 4. The length of the wire 10 meter and induced EMF 1.5. From this 3 value, we can calculate what is the velocity of the falling wire. Formula B is equal to E divided by B. After substituting the given values, we can get B is equal to 5 meter per second. D option. A metallic rod completes its circuit as shown in the figure. The circuit is normal to a magnetic field of B equal to 0.15 Tesla. If the resistance of the rod is 3 ohm. The force required to move the rod with the constant velocity of 2 meter second power minus 1 is. Right, in the given diagram, the length of the rod is 0.5 meter. The velocity of the rod is 2 meter per second. The magnetic field in which the rod moves is 0.15 Tesla. We need to calculate what is the force needed to move the rod outward from the magnetic field. Right? We know the formula for this question, that is F is equal to B square L square B divided by R. The force required to move the rod or circuit from the magnetic field is given by the formula F equal to B square L square B divided by R. Right? Write the given values. B 0.15 Tesla and the length of the rod is 0.5 meter and the velocity of the rod is 2 meter per second. And the resistance of the circuit is 3 ohm. Now substitute the known values 0.15 into 0.15 into length value 0.5 into 0.5 and into velocity value 2 divided by resistance value 3. 0.5, 15 into 15 into 10 power minus 4. 0.5 into 0.5, 25 into 10 power minus 2 into 2 divided by 3. Right. Increase of 15, 75, 25 into 250 into 10 power minus 6, or 75 into 5 into 10 power minus 5. 75 into 5, 25, 37 into 10 power minus 5, or 3.75 into 10 power minus 3 Newton. The required force to move the rod from the magnetic field is 3.75 into 10 power minus 3 Newton. Right, the option. Formula for the force needed to move the rod is F equal to B square L square B divided by R. Substituting all the values in this question, the force value applied is 3.75 into 10 power minus 3 Newton. Next, fifth problem. A metallic conductor of 1 meter length is rotated vertically its one end at an angular velocity of 5 radian second inverse. If the horizontal component of Earth's field is 0.2 into 10 power minus 4 Tesla, the voltage generated at both ends of the conductor will be. Right. There is a metallic conductor. Suppose the length of the metallic conductor is L, and which is rotates in the uniform magnetic field. Which rotates in the uniform magnetic field with an angular velocity of omega. The angular velocity of omega about this point. Right. When the metallic conductor is rotates, actually here magnetic field is acting perpendicular to the plane of the bow. Perpendicular to the plane of the bow. When the rod is rotates in this magnetic field, the rod cuts the magnetic field. So due to this, an EMF is induced across the two ends of the conductor. EMF induced across the two ends of the conductor. So the EMF induced across the two ends of the conductor when it is rotates in the perpendicular magnetic field is given by the formula E is equal to of B L square omega. One more formula is there in this region, that is E is equal to of B L square into omega. When a rod of length L is rotated with an angular velocity of omega in the uniform magnetic field, the EMF induced across its ends is given by the formula E is equal to of B L square into omega. Right. In this question, list out the given values. Magnetic field value is 0.2 into 10 power minus 4. 0.2 into 10 power minus 4 Tesla. Next, the length of the rod is 1 meter. Length of the rod is 1 meter. The angular velocity of the rotating rod, omega value also given, that is 5 radian second inverse. Right. Now the voltage generator, voltage means induced EMF. The induced EMF at the two ends of the conductor is given by E equal to of B L square omega. So 1 by 2, B value 0.2 into 10 power minus 4 or 2 into 10 power minus 5. And length of the rod is 1 square 1. And angular velocity value is 5. So 2 cancel. That is equal to 5 into 10 power minus 5 volt induced EMF. But the options are in millivolt and also in microvolt. So converting this value in microvolt, we can get 50 into 10 power minus 6 volt, or 50 into 10 power minus 6 is nothing but microvolt. So induced EMF is 50 microvolt. Suppose instead of the uniform metallic rod, there is a disc. Suppose a circular disc. So circular disc of radius of R. which is rotating with an angular velocity of omega in the uniform magnetic field. Then EMF induced at the center and one end of the, the edge of the rotating disc is given by the formula E is equal to half B R square into omega. If a uniform rod rotating with an angular velocity of omega in the uniform magnetic field, the EMF induced across the two ends of the rod is half B L square omega. If the disc is made to rotate in the uniform magnetic field the normal magnetic field, the EMF induced at the center and the edge of the disc is given by E is equal to half B R square into omega, or radius of the circular disc. Sixth one, the inductance of a solenoid having a core of 4 cm diameter and 2000 turns wound uniformly over a length of 50 cm on a cylindrical paper tube in a medium of Aries. There is a cylindrical paper tube. Of a length 50 cm and its diameter D is equal to 4 cm, and there is a solenoid is wound over this cylindrical paper tube, and the medium inside the solenoid is air, and the number of turns in the solenoid is 2000. Right? What we want to find out? The self-inductance of the solenoid. Right? We know that self-inductance of the solenoid in terms of total number of turns is given by L equal to mu naught N square A divided by L. Capital L self-inductance of the solenoid, small l length of the solenoid. Right? Mu naught permeability of free space, because the medium inside the tube is air. So mu naught, and n total number of turns in the solenoid, and area of cross section of the solenoid. This is circular area of cross section, therefore A can be written as a pi r square. Here diameter of the cylindrical paper tube is 4 cm means, then radius 2 cm. Now substitute all the known values or given values. Mu naught 4 pi into 10 power minus 7. This is constant. Permeability of free space value is constant. That is 4 pi into 10 power minus 7. Right. Into number of turns 2000 or 2 into 10 power plus 3. So the n square 4 into 10 power plus 6. 4 into 10 power plus 6. N square value. Next, area of cross section pi r square. So pi into r value 2 cm or 2 into 10 power minus 2 meter. 2 into 10 power minus 2 meter. So r square 4 into 10 power minus 4. Right, divided by length of the tube is 50 cm or 50 into 10 power minus 2. Right. So by simplifying this, we can get 12.6 millihenry. So after simplifying all these value, finally we can get self-inductance. That value is 12.6 millihenry. 12.6 millihenry. Third option. A coil has an inductance of 5 Henry, self-inductance value 5 Henry, and resistance of 20 ohm. Okay, the coil have both self-inductance and also ohmic resistance, that is 20 ohm. If a 100 volt EMF is applied, 100 volt EMF is applied, the energy stored in the magnetic field. The energy stored in the magnetic field is right. So there is an inductor which is connected to the source, DC source. Okay, voltage 100 volt, and self-inductance value is 5 Henry, and the resistance of the coil R is equal to 20 ohm. Right, we need to calculate the amount of energy stored in the magnetic field. amount of energy. Energy means the magnetic potential energy stored in the coil or magnetic potential energy stored in the inductor. Actually, the energy is stored, okay, where the magnetic field is exists in the solenoid. Where the magnetic field is exists in the solenoid. Here the magnetic field is exists only inside the solenoid, so energy is stored in this region. The energy stored in the coil is given by the formula U is equal to of L I square. U is equal to of L into I square. L value is 5 Henry. Okay, here current value wants to find out. We know that Ohm's law V is equal to IR, therefore current I is equal to V divided by R. Voltage value is 100 and the resistance value is 20. Therefore current is equal to 5 ampere. Current 5 ampere. So substitute the current value and the self-inductance value here. 1 by 2, self-inductance 5 and current value 5 square 25. 25 into 5. 125 divided by 2, 62.5. The magnetic potential energy stored in the inductor or in the magnetic field region is 62.5 joule or approximately equal to 63 joule. If the 63 joule is converted into kilojoule, it becomes 0.063 kilojoule. 0.063 kilojoule. Yeah. Energy stored in the inductor is given by U equal to of L into I square. L value is given, but the current value is not given. So first current value you want to find out. From Ohm's law, V is equal to IR or I is equal to V divided by R. V value 100 volt and the resistance of the coil is given, that is 20 ohm. Right, from the two value, current value is certain, that is 5 ampere. Substitute current value and the self-inductance value here. Then energy stored in the inductor is U is equal to 62.5 joule or after round of 63 joule. If it is converted into kilojoule, that value becomes 0.063 kilojoule. A option. An iron cylinder 5 cm in diameter and 100 cm long be wound with 3000 turns in a single layer. The second layer of 100 turns, a much finer wire, is wound over the first layer near its center. Okay, this is relative permeability for iron is 500. The mutual inductance between the coils. The mutual inductance between the coils or mutual inductance between the solenoid is given by the formula M is equal to mu naught or mu N1 N2 A into N. Here the given values are total number of turns in the first coil and the second coil. The mutual inductance formula in terms of total number of turns M equal to mu N1 N2 A divided by N. Right. So there is a iron cylinder whose relative permeability value is 500, on which the first coil is mounted on iron cylinder. The number of turns in the first layer is 3000, or first coil is 3000. Right. And the second layer also wound over the first layer at its center. The number of turns in the second layer N2 is equal to 100 turns. Right. Next, the diameter of the cylinder value also given, that is 5 cm. And the length of the cylinder or length of the coil L is equal to 100 cm or 1 meter. 100 cm or 1 meter. So total number of turns in the first coil or first layer is 3000 and total number of turns in the second layer is 100. The two coils are wound on the iron cylinder whose relative permeability value is 500 and diameter of the cylinder and the length of the cylinder are 5 cm and 1 cm. The formula related to this question is M is equal to mu N1 N2 A divided by L. What is mu? permeability of ion, or permeability of ion mu is equal to mu naught into mu r. So formula mu naught mu r n1 n2, area value is not given, so this is circular area of cross section, so pi r square divided by n. Right, mu naught 4 pi into 10 power minus 7, and relative permeability of ion is 500. Number of turns in the first coil 3000, and number of turns in the second coil 100 into pi into r value. Diameter is 5 centimeter, therefore the radius of the cylinder 2.25 centimeter. So r square 2.5 into 10 power minus 2 the whole square, right, divided by length of the cylinder is 100 centimeter. 100 centimeter is nothing but 1 meter. We can get 0.37 unit of mutual inductance is secondary. So mutual inductance of the two coils is 0.37 secondary. B option. An aeroplane having a wingspan of 50 meter. The wingspan of the aeroplane is 50 meter. Flies north over a locality where the vertical component of Earth's magnetic field is 4 into 10 power minus 4 Tesla. If the potential difference developed between the wings is 2 volt, then what is the velocity of aeroplane? Right. Okay, motional EMF. Once again, motional EMF E is equal to BLB. Therefore, V is equal to EMF divided by BL. Right. Given values are induced EMF or potential difference across the wings is 2 volt. Next to the horizontal components or vertical component of X magnetic field value is 4 into 10 power minus 4 Tesla, and the length of the wingspan L is equal to 50 meter. Right. Now substitute E value 2 divided by B value 4 into 10 power minus 4 into length value 50. Right. 2 divided by 200 into 10 power minus 4. 2 to cancel. So 10 power minus 2 goes to numerator. So 10 power plus 2 volt. So we'll have the velocity 100 meter per second. So velocity of the aeroplane is 100 meter per second. But in option, okay, all the options are in terms of a kilometer per hour. So we need to convert meter per second into kilometer per hour. So 100 meter per second is equal to 100 into 1 meter per second is equal to 18 divided by 5 kilometer per hour. 20 into 18, 360 kilometer per hour. 100 meter per second or 360 kilometer per hour. A transformer has an efficiency of 95%. When a voltage of 120 volt is impressed means applied across the primary. The current in the primary is 1.85 ampere. The voltage across the secondary when it delivers 150 milliampere is. Right. We know that the efficiency of the transformer is ratio of output power to the input power. Right. Output power, output voltage into output current divided by input voltage into input current, or primary voltage into primary current. Right. Efficiency value is given, that is 95%. So 95% is equal to another given values are the voltage which is applied across the primary, that is Vp value is 120. Next, the current in the primary is IP value is 1.85 ampere. Next, and voltage across the secondary wants to find out it delivers 150 milliampere current in the secondary current. So the secondary current IS is equal to 150 milliampere or 10 power minus 3 ampere. Right, substitute Vp value, Ip value and IS value here. So 95% or 95 divided by 100 is equal to Vs value wants to find out. So Vs, IS value 150 into 10 power minus 3 divided by Vp value 1.85 and Ip value is 120. Right. Therefore, Vs is equal to 95 into 1.85 into 120 divided by 100 into 150 into 10 power minus 3. Right. So, right. After simplifying this, we can get a Vs value that is 1006 volts. Efficiency of transformer eta is equal to output power divided by input power. Output power is equal to product of output voltage into output current. Input power is equal to product of input voltage into input current. Input voltage, input current and the secondary voltage are given and also efficiency value also there. So from that 4 value we can calculate the secondary voltage. So secondary voltage attained in this problem is 1406 volts.